Hi everyone, I'd like to welcome you to Mr. Q Does Math, the video show where Mr. Q, that's me, does math problems. Today we're going to be practicing factoring when the a value of our quadratic equation is greater than 1. So just to review, the standard form of our quadratic equation is ax squared plus bx plus c equals 0. We're going to spend our time looking at problems where the quadratic equation has an a that's bigger than 0. So some examples could be anything that falls along these lines. So the only difference between what we were working on the other day and what we're working on now is that the a values here are no longer just a coefficient of 1. So the first example we'll be working through today asks you to factor 7x squared plus 19x minus 6. And we can do this in one of two ways. The first method is the guess and check method, and I actually don't prefer to use that method because you can get the answer correct, but you don't exactly know if you've shown all the possible correct solutions, and you haven't really shown that you know what you're doing, you just shown that you can guess properly. So we're going to do the grouping method because it works in all cases and it's just more mathematically correct. So let's begin. The first thing we're going to need to do is look at our a values. Our a value again is the term that corresponds with the x squared, so for us it's going to be the 7. So our a is 7. And what are the factors of 7? The factors of 7 are actually really simple, so it's just 1 and 7. And what that tells me is that when I'm done with this problem, I should have two binomial terms that look something like this. X plus or minus some value multiplied by 7x plus or minus some value. And the only reason I write this here is so that I know when I'm done I should have my first term of one of my binomials be an x and the first term of another of my two binomials be 7x. And it's just something that keeps me focused on where I'm going, so I'll know when I get there. The next thing we need to do is multiply our a and c terms. Our a value is 7 and our c value is negative 6. And that's going to be negative 42. Now that we've done these beginning steps, we can move on and solve the problem just like we're used to solving. What this tells us is that we are looking for two numbers, just like we were previously, that add to 19, which is our b value, and multiply to negative 42. So, I'll write that down. We're looking for two numbers that add to 19 and multiply to negative 42. So just as we were doing when our a value was simply 1, we'll start by factoring, getting the factors of 42. So that's going to be 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work, 6 and 7, 8 doesn't work, 9 doesn't work, 10 doesn't work. That should be all of them. So now that we have the factors of 42, we're looking for negative 42. So we need to set up our table of possible values that could make a product of negative 42. So that would be negative 1 and 42, or 1 and negative 42, negative 2 and 21, or 2 and negative 21, negative 3 and 14, 3 and negative 14, negative 6 and 7, or 6 and negative 7. Okay, so we're looking for, again, two numbers that add to 19 and multiply to negative 42. So all these sets of numbers multiply to 42, but we need to see which add to 19. So let's get a sum column here. Negative 1 plus 42 is going to be 41. 1 plus negative 42 is going to be negative 41. Negative 2 plus 21 is 19. 2 plus negative 21 is negative 19. Negative 3 plus 14 is 11. 3 plus negative 14 is negative 11. And in case you didn't notice, there's a pattern that I can see coming out pretty clear here that it's basically the opposite. So we just have to do the numbers in this column, negative 6 plus 7, which is going to be 1. And then this should just be the opposite, which is negative 1. Now, we're looking for two numbers that add to 19 and multiply to negative 42. So, negative 42, all these work. And here, these numbers add to negative 19. Now, in the previous cases, we could just write x minus 2 multiplied by x plus 21 and be done. But because our a value is not going to be 1, that method doesn't work anymore. So what we have to do is plug these values into the original equation, which is this guy right here. So this would look like 7x squared minus 2x, and I just did the minus 2 because this value is negative, plus 21x, which is from here, and minus 6, which is just our c value from the original equation. And where the grouping comes in, which gives this method of solving it its name, is that we're going to break our four terms here into two groups. And with this group, I can see that there's an x squared and an x, so we can factor out at least one x. And we're left with 7x minus 2. And over here, we can factor out a 3. And we'll have 7x minus 2. So here I see that we have 7x minus 2 here and 7x minus 2 here. So we can just factor that out again. So our first value here will be 7x minus 2. And what we have left over is going to be our x term here plus 3. So factored out, this binomial is going to be x plus 3. And I know that might seem a little weird, like why we do all these things, but I just recommend that you follow this procedure, and after a while you'll be able to see factors much more quickly and be able to solve the problems faster. But especially in the beginning, take your time, write out as much as you can, and then you'll be able to do it much more efficiently. But before we're done, let's just use our FOIL and make sure that this works. So 7x times x is going to give us 7x squared. Outside, 7x times 3 is going to be plus 21x. Inside, negative 2 times x is going to be minus 2x. And last is going to be negative 2 times 3, which is negative 6. Combine our like terms, so we'll have 7x squared plus 21x minus 2x is 19x minus 6. Is that what we started with? It is. So we can say we were successful in solving this problem, and then just rewrite our answer off to the side. And box it off.